All right, let's take a look at problem number 2 here. It gives us this equation, and what it wants is, on problem 2, it wants us to find the critical points. Now, with a guy like this, his graph basically is doing this. It's coming down, it's going up, and then it's coming back down. What we're looking for are the critical points. This point right here, it's relative minimum. This highest point within this section, the relative maximum. And then this point of inflection where it's spinning this way and then it starts spinning back the other way, which will be in the middle of these guys in this situation. So in order to find what that is, in order to find where that point's located, what I do know is if I drew a tangent line right there, it would touch just in that spot. And it would be horizontal like that, unlike a tangent line right here would be at an angle and then a different slope and everything. Now what is this slope? This is a slope of nothing. Now remember, the derivative is what tells us the slope at any point on this curved line here, on this guy right here. So we take the derivative, it'll tell us the slope anywhere on here. Well, you and I want to know, when is the derivative equal to 0? Same thing up here. This guy would have a slope of 0. So if we take the derivative, set it equal to 0, that'll tell us where that and that are located. Then we'll figure out how to find the point of inflection. So the first thing we want to do here is let's take the derivative of it. Bring the 3 down, that's 3x, the exponent drops to the second power, plus 2 comes down, 6 times 2 is 12x, and the 1 just goes away. So here's our derivative. Now we said, let's take that derivative and see when is it equal to 0. That's going to tell me this spot and this spot. When is the slope? Because remember, the derivative is that magical equation that tells you the slope anywhere on this original line. We want to know when is it 0. Looking at this equation here, basically I notice they both have a 3 that can be factored out. It has x squared and an x, so an x can come out also. So the first thing I'm going to do is I'm going to pull out a 3x. I'm going to realize that left behind is x plus 4. Now this times this is 0. That means either this comes out to be 0 or that must be a 0. So I know if I can either 3x is 0 or the x plus 4 is 0. Solving it, I get x being 0 or x being negative 4. There are 2 of my critical points. So I know 0 comma something and negative 4 comma something. Oh, not 0, sorry about that. Negative 4 comma something will end up being these guys. Now let's look where the heights are to determine them first. Since it's positive, I do know it's that way, so I will know that actually this is going to be the minimum, 0 something, and over here at negative 4 will be the maximum. But again, I didn't ask you to name maximums and minimums. I just said give me the critical points. So to find these critical points, if I know what occurs when x is 0 and when x is negative 4, how do I find the y value that goes with it? All I'm going to do is I'm going to plug 0 back into the equation. 0 cubed plus 6 times 0 squared plus 1. That's just going to be a 1. 0, 1 is one of the points. Plug negative 4 in. Woo, a little big. Negative 4 to the third will be negative 64. Negative 4 squared will be 16. 16 times 6 is 96 plus 1. Okay? So lose 64, gain 96. 64, 74, 84, 94. That looks like a difference of 32 to me. Plus 1 makes it 33. So this will be negative 4 comma 33. So as we said, this is going to be our maximum right here. It's at a height of 33. This guy's a height of only 1, so it's our minimum. Now, how do we find the point of inflection? The point of inflection is very simple to do. It's going to be done the exact same way you did here, except for you're not going to take the derivative of this. You're going to take the derivative of the derivative, the second derivative. Set it equal to 0. Solve it, boom, there gives your x value. So I'm going to take this derivative, I'm going to take the derivative of it. So here's how we write it. F, second derivative of x. Bring the 2 down, that's going to be 6x. Plus, there's a 1 right here. 1 times 12 is 12, and that's what the second derivative is. Now we set it equal to 0. Move your 12 over, divide, you're going to see very quickly x is negative 2. Because 6 times negative 2 is negative 12, plus 12 is 0. I can see that. So I know there's a critical point at negative 2 comma something. Now notice I could see that it was also between 0 and -4 was -2. I knew that was going to happen in this problem. So I plugged -2 into the equation. -2 to the third, do it right here, is -8. Plug in -2. -2 squared is 4 times 6, 24 plus the 1. -8, that's 16 plus 1, we got 17 here. So here are our 3 critical points. I didn't ask what they were, but we will know. That guy is our point of inflection. There's another critical point, which is the highest point, so that's our relative maximum. And finally, this guy, which is our relative minimum right here. So we actually can identify where those points are if we wanted, but I didn't ask you. I just said, give me the 3 points that are critical points. And that's how we do it. 1, take the derivative. 2, set it equals 0. 3, solve it for x. 4, plug it back into the original equation, that x value, to get your y value. You then have an ordered pair. Then you do the second derivative, set it equal to 0, solve it for x, plug that x value back into the original equation. Boom, there's going to be your point of inflection. You're done. Just follow those steps. You'll have it every time.